Hello again. In this problem, we will be working on some volumes of revolution, and I'll show you the same problem using both the disk method and the shell method, and you can kind of see which one would be easier in this specific problem. So let's start by taking a look at our problem, and we have the region bounded by y equals 2x, y equals 4, and x equals 0, and we're hoping to rotate that about the x-axis. So I always like to start these problems by drawing what's happening. So we have y equals 2x, which looks something like this. Y equals 4, which would look like that. And then, of course, x equals 0 would just be the y-axis. So this shaded region here is what we're hoping to rotate about the x-axis. So in this case here, instead of using the disk method, it would be the washers, because we would have this inside region that's missing. So if you recall, when we're using the washer, the disk method about the x-axis, the formula is going to be pi times the integral of the area squared. I just like to think of it as the area of a circle, pi r squared. So if we plug in our bounds, which are going to be the x bounds, which would be this point here, which would be x equals 0, and this point here, we could figure out that that is x is equal to 2. How do we know that? Well, just set the curves equal to each other. 2x equals 4, so x would equal 2. And then our function, this is the washer method. So if we modify the disk method, we have the outer area squared minus the inner area squared. And so the outer, or the top curve in this case, would be y equals 4. The inner, or the bottom one, would be 2x. And we would square that as well. Okay, so performing some quick integration here now. After we simplify, we get 16 minus 4x squared. And now we will integrate, and we would get pi times 16x minus 4x cubed over 3 from 0 to 2. And of course, that would give us 32 minus 32 thirds. So we would get 64 pi over 3. I know that was kind of fast, but you can check the math on your own. But now we're going to go ahead and do the same problem using the shells method and make sure that we get the same answer. So washers method is over here. We're going to go ahead and start the shells method here. So remember, the shells method, if we're rotating about the x-axis, that integration will have to be with respect to y. And shells is like the volume of a cylinder, so it's like 2 pi rh. So 2 pi times the integral of the radius in this case, since we're working with y's, will be that curve here. And let me use a different color for you. Times the height, which is just going to be y. So y times the radius in terms of y. That would be our formula for shells here. So plugging some stuff in now. The integral from c to d, those are just going to be our y bounds now. Our y value here would be 0. This 2 was our x bound. We'd have to plug that back into the equation to x to get y equals 4. It would be our y bound. And then we would need the radius in terms of y. Now, the radius is this red line, so essentially what we're doing is we're just going to get this curve, y equals 2x. But that's in terms of x. We have to get it in terms of y instead. So x would equal y over 2. So times y over 2. Now, quickly solving this again, we get y squared over 2 dy equals 2 pi. Now we're integrating, so we'd get y cubed over 6. And so that's from 0 to 4. That'd be just pi over 3 out in front. And 64 when we plug in the 4 cubed. So ultimately, again, we get 64 pi over 3, which matches the answer up here. Excuse me. So now, the question is, which one was easier? And I mean, ultimately, it's personal preference. In this one, they're about the same. You didn't have to worry about an inner and an outer radius when we worked with the shells method. So I'd say maybe that was a little bit easier. But ultimately, you can use either one. There are certain problems where you'll actually have to split it into 2 different integrals if you use one method over the other. So if you ever find yourself having to do that, you should probably take a look at the other method. But that was a quick recap of how to use both methods, and I hope that helped.